CMS safety meetings now include a quiz feature. This can be viewed online, which is convenient for training employees on safe practices and easy to administer. Registration and quizzes are free. The video's comment section highlights the link in blue. This presentation will explain trenching and general excavation requirements, protective systems, and the responsibilities of a competent person to identify major soil classification types and hazards associated with excavations. Locating underground utilities pose threats such as electrocution, explosion, environmental contamination, and property damage. Underground utilities should be hand-exposed using hydro-excavation prior to excavation of the trench. One call system establishes a communication link between those who dig underground and those who operate underground facilities. The systems require excavation contractors to notify the One Call Center for any intended digging or construction activity. The One Call Center then notifies the owners of underground facilities that digging or construction will occur at a given location. The facility owners or their contract locator are then to proceed to the excavation site and mark the location of any underground facilities in the area. Hydro-excavation equipment includes onboard water tanks that generate a pressurized stream of water to cut through the soil. Powered pumps boost the water jet's pressure to several thousand pounds per square inch, making it easy to cut through dirt and compacted soil. Slurry mixtures of soil and water are directed back into the truck or trailer storage tank by suction hoses attached to the articulating boom. A vacuum blower or vacuum pump creates suction on the vacuum hoses to recover the slurry. The vacuum system collects sludge deposited in the debris tank. For hydro-excavators operating in frozen ground, some models feature a boiler that heats the water before pressurization. Tips for safe hydro-excavation. When using hydro-excavation, the entire width of the underground piping should be shown, including both edges. Once the depth has been determined, a stake or PVC pole should be used to mark it. Never use a water pressure wand to probe. Never point a high-pressure water stream at another person or yourself. When running compressors, always wear hearing protection. Keep large rocks and tools away from the hole. These can fall in the hole and damage the pipe you are exposing. The general excavation requirements include marking the location of underground utilities like sewers, telephones, fuel lines, electric lines, and water lines before excavation begins. Lines and marking in the area of excavation or trenching may include APWA, Uniform Color Code, and APWA, Utility Location Marking. For trenches, greater than 4 feet deep, a stairway, ladder, ramp, or other safe means of egress must be provided so that employees need not travel more than 25 feet laterally. When using a ladder, please ensure that it is secured from falling and extends 3 feet past the trench edge. Always use the right ladder for the depth of the trench. Precautions should be taken so that the atmosphere within the trench does not become hazardous. Under the right conditions, trenches can become a form of confined space where hazardous gases can exist. Operations such as welding, cutting, and cutting a pipe produce harmful vapors, which can harm employees if not properly managed. In locations where H2S gas, CO, propane, methane, or other dangerous gases could be expected to occur, gas monitors should be used to ensure the atmosphere is safe. Mechanical ventilation, such as a fan or blower, can also be used to maintain a safe atmosphere where natural ventilation cannot occur for environmental reasons. Monitor tests must be done within the trench to detect engulfment gases. Oxygen deficiency of 19.5% or less. Oxygen enrichment of 23.5% or higher, and flammable gases or vapors. Monitoring should be conducted at multiple levels because harmful gases can separate and have a layered effect. The sniff test must cover the top, the middle, and the bottom. Employees shall not work in excavations where there is accumulated water or in excavations where water is accumulating without taking precautions to control the water accumulation. A portable water pump can control water in the trench by pumping the water out. To control surface water from entering the trench, the operator can create earthen dikes or diversion ditches to drain or divert surface water. Spoil from excavation should be placed no closer than 2 feet from the edge of the excavation to prevent soil and rocks from falling into the trench. Tools and equipment should not be placed near the edge of the excavation because they could fall into the excavation and hurt someone. Despite being buried alive, you are still alive. This is one of the most horrifying things that can happen to a person. While down in the trench, you hear a slight rustling of dirt, and you turn around to see the beginnings of an avalanche. Your every move is in slow motion as you scramble to the surface. Feeling trapped in the blackness, you can't move a muscle. It is tragically true that this terrible nightmare comes true more often than we care to imagine. Every year, hundreds of workers are killed and thousands injured by cave-ins. Consider that just 1 cubic yard of dirt weighs nearly 2 tons. That's why cave-in tragedies can occur even in small excavations. A trench just 4 feet deep can become a shallow grave. Those who manage to survive often suffer severe and crippling injuries because of the crushing weight of the soil. Surcharge loads are loads applied to the edges of a trench, which stresses the trench walls. A surcharge load can make trench walls unstable and can lead to cave-ins. Some examples of surcharges include spoil piles, heavy equipment, and vehicles. It is necessary to protect employees from cave-ins using protective systems. That keeps the soil from falling while workers work in the trench. The 3 types of protective systems are sloping benching, shoring, and shielding. Shoring is the process of installing aluminum hydraulic or other types of supports to prevent soil movement in cave-ins. This is often necessary when excavating a trench or working in an area where there is a possibility of the ground giving way. A benched excavation, also called benching, can be defined as a type of excavation that consists of a series of horizontal steps with near vertical surfaces between them. This is a safety measure to prevent the excavated walls from collapsing inwards and trapping the construction workers. Shielding is the process of protecting workers from falling debris or being hit by equipment. Shielding can be done with barriers, nets, or other types of protective devices. Barriers can be made of wood, metal, or concrete. They are placed around the perimeter of an excavation to prevent people and equipment from falling into the hole. Trench boxes are different from shoring because they are intended primarily to protect workers from cave-ins and similar incidents instead of shoring up or otherwise supporting the trench face. The excavated area between the outside of the trench box and the face of the trench should be as small as possible. The space between the trench boxes and the excavation site is backfilled to prevent lateral movement of the box. Shields may not be subjected to loads exceeding the systems designed to withstand. When entering and exiting a shield, employees must be protected from cave-ins. After shields are installed, they must not be subjected to loads greater than their rated capacity and cannot move laterally in the trench. The engineer's certificate for each shield must be on the job site while the shield is being installed or removed. The shield must protect employees from falling tools or loose rocks. When handling and placing trench shields, always use taglines. Trench boxes are generally used in open areas, but they also may be used in combination with sloping and benching. The trench box should extend at least 18 inches (0.45 meters) above the top of the ditch or surrounding area. This can be accomplished by providing a benched area adjacent to the trench box. Earth excavation must be a depth of 2 feet (0.61 meters) below the shield permitted, but only if the shield is designed to resist the forces calculated for the full depth of the trench. The amount of sloping and benching chosen depends on soil factors such as cohesion, moisture content, and soil particle size. Soil can be classified for sloping purposes based on its characteristics. According to soil type and angle ratios, the maximum horizontal slopes for excavations less than 20 feet (6.09 meters) are as follows. Stable rock has a maximum slope angle of 90 degrees. Type A. Soil's maximum slope is a 34:1 depth ratio with a 53 degrees slope angle. For Type B soil, the maximum slope is 1 height to 1 depth with a 45 degrees slope angle. The maximum allowable slope for Type C soil is 1 1/2 height and 1 depth ratio with a 34 degrees slope angle. Shoring can be used where braces and cylinders support the excavation walls while work is being performed. To determine the correct placement of the cross braces, the materials used in shoring should be free from defects and used by the manufacturer's specifications. There are 3 types of soil. Stable rock means natural solid mineral matter that can be excavated with vertical sides and remain intact while exposed. The others are classified as Type A, Type B, and Type C. Type A soil is made up of cohesive soils that are high in clay content. These soil do not fissure, crumble, or show disturbance. Type A soils cannot be labeled if they are vibrated by heavy equipment. Type B soils are cohesive soils that are somewhat granular, previously disturbed soils, silty loam, and sandy loams. They are very loamy and contain a relatively equal mixture of clay, silt, and sand. Type C granular soils such as gravel, sand, sludge, and loamy sand. Soil from which water is seeping in from the side or standing at the bottom. OSHA defines a competent person as someone who is capable of identifying existing and predictable hazards in the surrounding area which are unsanitary, hazardous, or dangerous to employees. Excavations must be inspected daily by a competent person before employees enter the trench. The competent person looks for evidence that a cave-in or failure of the protective system is likely to occur. Stopping the job and ensuring that occupants are safe is the responsibility of competent persons. If a competent person discovers conditions that could result in cave-ins, hazardous atmospheres, or other hazardous conditions, he should stop the job and remove the employees from danger. A new ditch inspection is required if weather conditions make the trench hazardous. We appreciate you watching the first CMS safety meeting. Stay up to date by subscribing. A lot of new meetings will be added, as well as creative measures.